How are we doing on time, Val?
You're doing great.
Okay. The chemical reaction of hydrogen and oxygen during combustion. Remember I told you? First of all, you've got humidity in the air. The humidity in the air is pulled in. So if it's a humid day, the air that you're pulling in for combustion is going to have a lot of moisture in it anyway. A rainy, cold day. Well, what do we get around here in the fall and the spring? Rainy, cold days. What do you get in the wintertime? Humidity level's different, but you still have moisture available all the time. So that as you pull this in, you're going to have moisture. H2O is going to be built up in this stuff. The chemical reaction of hydrogen and oxygen forms water vapor. It's just the natural act of doing it. It's what happens chemically. In a typical, there's a company called John Zink, if any of you are interested in looking into this any further from the chemical standpoint or just from an interesting standpoint. John Zink started up in the oil fields in the 1850s, I believe, and the company really helped develop a way of cracking and distilling fuel as we know it today from crude oil. And they basically wrote the book on combustion. And they spent thousands and thousands of man-hours studying combustion and what needs to be done, can be done, how to control it, how to utilize it. And the average boiler on any given day can have as many as 123 chemical reactions going on simultaneously in the flame, depending on the quality of the fuel that's being used, the amount of air, the barometric pressure, the dew point, everything. It all has an impact on it. But 123 different things going on in there simultaneously, chemical reactions. One of the things we look for, and we're not going to get into all of those, but as we look at this, when we have these, if you don't have either ignition, fuel, or oxygen, it's not going to fire. So if you have a boiler that's not firing, one of those three items is missing. That's all it takes. You basically are lighting a match and throwing it on some Kingsford charcoal briquettes. I mean, that's it. It's that simple. Now, all of the peripherals around it that surround this, all the safeties that are built into it are there for a reason, and it's a good damn thing that they are. I personally have been injured by them. I know a lot of people that have been injured. I actually know a few people that have been killed while working on these boilers. It's not an easy thing to just pass over in your mind once that occurs in your life, but you have to have one of these three things here to make that combustion occur. So stop. If it doesn't fire, what am I missing here? Do I have oxygen? Do I have fuel? Do I have ignition? It's one of those three that's not occurring. The burner function. Sorry for the quality. These things have been copied several times and it's kind of poor, but the purpose of the burner is obviously is to, as I said before, it's going to blend or mix the fuel. In this case, let's talk about natural gas fuel, and it's going to blend it with air, and then it's going to ignite it. And then it's going to supply that continuous demand that's necessary to keep that heat process going. Emissions. Here's something that I want to hit on that is really, and this is where you guys have got to start putting your heads. A few years ago, it's been about 11 or 12 years ago, I did a lot of traveling for a company, and we were involved in a lot of this commissioning process on burners. We in America have always had relatively cheap fuel, and we've also had relatively slack laws. When you go to other countries, Canada, for example, is death on this. For one country. There are many countries. All of Europe is absolutely death on emissions. We haven't got it here. It's starting to come into play, and it's coming into play in the typical manner that it comes into play. The most prominent places that I worked on where they were really concerned about this, about emissions, were government installations, obviously. Government installations have a criteria that really requires a very stringent viewpoint towards emissions. That is a trickle-down effect, and it's going to hit us, guys. It's going to hit all of us sooner or later. Some of you younger guys are definitely going to see it. What we want here is we want the highest efficiency out of these things. We want them to be friendly to the environment, but we also want them to be safe. When we set something up and we install something for you in your building, we try to do all of these things so that each thing is addressed as an individual component, and together they work as a unit. Safety. briefly, I want to tell you just a couple of things. I have a routine, and I meant to print it out. I will get it printed out, and if you need a copy of it, I thought I had it, but I didn't have it available to me this morning. I should have looked at it earlier. When you go in to start...
We can send it out.
Yeah, we can send it out to everybody. When you go into a boiler room, I don't care if you've been in this boiler room 100 times. If you go in and there's a problem, the first damn thing you want to do is shut the gas line off. Shut the main gas off. Shut it off. Okay, now what you want to do is you want to make sure that this boiler or this burner assembly operates correctly. You want to run it through its paces with the gas off. Reset whatever resets you have to do and run it one time with everything shut off, because you want to make damn sure this thing shuts off. It should trip on flame failure. If it doesn't, don't go any further. You got problems. But make sure that you always shut the gas off before you ever start this process. Finally, when you go through this step, one of the last steps that I almost always require is that when you start this boiler, finally you've got the thing, you think you've got it by the tail, you've got this thing in control, you're the master. The last thing you want to do is kiss it on the lips and walk out the door and turn the switch on as you do it. Stand away from the boiler when it fires the very next time. I can't stress this enough. This is a step that you absolutely cannot justify in your own mind. And I'll tell you a brief story. 750 horsepower boiler. It was a dual fuel prior to this. It was propane and it was fuel oil. At that time, this was during the 70s, and there was a freeze on natural gas. So they were not allowed to hook natural gas to it. Later on, in the 80s and 90s, it was in the 90s somewhere, the company got natural gas put in. So now we had a three fuel burner, very unique and very specialized, and each section of it, whether it be on natural gas, fuel oil, or propane, had to be adjusted accordingly. I adjusted the first two and went back to the propane as a final step because it had always run on propane. Should run right? Well, unbeknownst to me, because this was a very large installation, outside they have large liquid propane tanks. The last thing you want is liquid propane going into this thing because it's going to expand rapidly and it's going to blow like a damn bomb. So outside they have another boiler and another boiler house that is supposed to preheat the liquid propane and turn it into a vapor so that when I open my valve, I get vapor. This time I didn't, because I didn't know, and there was no way to know. This was a quarter of a mile away where this other place was. Nothing told me whether that one was on or off. I made an assumption that it was. And I had been in this room several times. And I went ahead and lit this boiler off, and it started to light, and it puffed, and it lit, and I bent down to look to see inside the window. Now you got to bear in mind, a 750 horsepower, the control panel is right about here. It's just about all you can do to reach the bottom of the control panel. So you have to have a ladder or something to get up to it. They had this thing. I'd moved it out of the way. This thing lit off. When it lit off, liquid propane, it lit off beautifully. But there wasn't enough room for it to all expand. So it blew the damn doors open. And it blew the exhaust out the back of it. And when it blew the doors open, I was like this. And they blew open over the top of me. Otherwise, I wouldn't be standing here in front of you. At the same time, the residual explosion, just the explosion, the expansion of the air in the room, literally threw me from where I'm standing to the wall and knocked me out. To this day, I wear hearing aids partially because of that. It was an explosion like I've never seen before. And it was all due to the fact that I thought I was in control, because I thought that I knew what I was doing. I think I did know what I was doing, except I skipped one of my own critical steps. I didn't step out of the damn room when I turned the switch on, because I'd already had it on for two other fuels, right? What's wrong? Everything's working. Everything's great. Flip, bing, boom, bang, that's it. It's done. It lifted a 5-foot diameter stack off of the top of the boiler and set it over. It blew the doors out of the boiler room. It cracked the glass in the controls behind me. Tremendous power. And that wasn't from anything except the air expanding from the explosion. And it was all due to liquid propane, something that I didn't know that I had a problem with. Should have checked it, didn't check it, my fault. I'm here to tell you the story, and thank God I am. But You can't be careful enough with these things. Gas fuel contents, how are we doing time-wise? Okay, gas fuel contents. When we're dealing with gas and fuel, what you're doing is you're mixing these chemicals up. There's a high dollar term, and if you've never heard it, I'll use it because I like to use high dollar terms. It makes me look important and really, smart. But stoichiometric is the name of the word. And stoichiometric is nothing more than, if you look it up in the dictionary, it's a combination of dry gases. The end. They could say that, but why would they? Because now I can impress you with the name stoichiometric. I can tell you that, just like I can tell you about the avalanche breakdown point of a Zener diode. Wow, that sounds big. That's a big thing. What you get when you mix these two, we breathe air, 21% oxygen, 78% nitrogen. The biggest portion of what we breathe is nitrogen. We don't use it. It's just here, it's a transporter. When you go and heat it though, now we have a problem. Because now we've heated this nitrogen up and we've dissipated it out. It has a tendency, as any gas does, as it expands, to condense and get smaller again after it cools down. As it cools down, it picks up all the other crap that's around it and takes it with it. The term that's being used, and should be used for all of this, is fuel NOx, N-O-X, and it's nitric oxide. Nitric oxide is also referred to sometimes when it comes down in a precipitative form as acid rain. It was a byproduct in Europe for many years, and that's why they are absolute death on it now. NOx is the single biggest thing that they look at over there. No nitric oxide, period. Whatever it takes, you don't build it. And the way you don't build it is you have a particular style in your boiler of doing this stuff. Fuel heating values, I just wanted to give you a real quick thing here. If you look at natural gas, typically we use a number of 1,000 BTU per cubic foot. That's typical of what we use here in this industry. Propane is 2,500. Now that's 2.5 times the BTU, the heat content of natural gas. Propane, actually the flame is so hot and it's in a spectrum of light higher than we can see, you can't or shouldn't be looking at a propane fuel that's being combusted because it's so bright. It's going to burn your eyes. Now, I'm not talking about at home. I have propane at home. I'm talking about when it's compressed and put into a flame. The propane is extremely hot, very hot, high temperature. Manufactured gas, LP gases. You also have fuel oil, same thing. Fuel oil has a higher carbon content in it, so it has a more yellow flame, but it's a very bright yellow flame, almost a white yellow flame. They're now doing in an industry thing across the country, again, to reduce the impact, the green foot thing and the green leaf thing. A lot of the sewage treatment plants are going to a style of burner that actually takes and uses human waste as the fuel. And they have a nice name if you ever hear it. It's called digester gas. So sometime if you're ever somewhere and you need to excuse yourself, say it's not a problem, I have digester gas, and you're done. I mean, that's what they use. But they actually take the gas and the fecal matter itself, dry it out, and burn it. But it's a very low BTU content, and therefore it makes a really nasty flame. And you have to recover all of that other crap that's in it because you're not getting it hot enough. So the solution to some of this stuff, I've already talked about this, air, how much of it is. In incomplete combustion, if we have something going on in the system that for some reason you're not getting the right fuel-air mixture, sure, it's burning, but how is it burning? That's the question. You're going to produce carbon monoxide. Carbon monoxide is obviously dangerous to humans, is dangerous to everything else. What we want to produce is carbon dioxide. Carbon monoxide is the byproduct, and it's another thing we measure in the flue gas analysis. How much is there? By law, you're allowed to have 200 particles per million in the stack going up. That's too much, because if everybody was putting out 200 particles per million, we probably couldn't breathe. What you typically want to see is below 10 particles per million when you're looking at this. It's very, very difficult, except on a very high-end burner assembly, to get 0. But you have to maintain it at a very low point. The reasons you want to do this is because you want to keep this flue gas from becoming noxious and bad. these are kind of an explanation. I don't want to go too much into this because this really has to deal with setting up your individual boiler.